Hey everyone, we're going to take a look at using Couchbase Server in a Golang development application. So this is going to be a web application. We're going to be using Couchbase as our NoSQL database. This is only going to be a RESTful API, so we're not going to be developing a front end in this particular tutorial. It's going to be strictly Golang, strictly Couchbase, and then you can go ahead and apply any kind of front end you want, whether that be a mobile front end, Angular, React, whatever it may be. It's pretty flexible in that matter. So there are a few requirements that must be accommodated first before going along with this tutorial. So first of all, you have to have Couchbase Server installed. So the version that we're going to be using in this particular tutorial is version 4.5. But as long as you have Couchbase 4.0 or higher, you should make out pretty well. I am using Golang 1.7, but if you're using 1.6 or I think even 1.5, it should work out fine, or anything higher should work out fine as well, as not a lot of stuff has changed between those particular versions. So with that said, let's go ahead and create a new project. So of course this is going to be at your Golang path. So what we're going to do is we're going to say make directory. We're going to say -p. We're going to say go path. Source, for me it's going to be github.com/nraboy, and then let's go ahead and call this project CB project. This is assuming you have the Go path set up and everything configured correctly as far as Go is concerned. So I did create it. I'll navigate into it now. So it's cd go path source github.com/nraboy, and then CB project. Perfect. So as of right now, there's nothing in that particular project. What we want to do is we want to create a single file. All of our code is going to be inside of this one file. So let's go ahead and say touch main.go. And really, you can call this project whatever you want. You could even call this Golang file whatever you want. But if you want to follow along precisely with what I'm doing, let's go ahead and keep it consistent. The next thing that you want to do is, so I do have Couchbase running on another machine of mine. It is Couchbase again. It's Couchbase 4.5. Again, the version isn't too important. But what is important is we're going to be using NQL queries inside of this project. So these are SQL-like queries against NoSQL data, and that requires that you create an index. So I do have a database, not a database, a bucket here called example. That's what we're going to be using, but there are no indexes created for that particular bucket. So we can use the query workbench. Or if you're not using the same version as me or higher, you can use the Couchbase command line tool to create these indexes as well. So what we want to say is we want to say create primary index on example using GSI, and then execute. And that'll create one index for us. Again, since this is a basic project, this one primary index will be fine for us. In a production application, you probably want to create more specific indexes for performance reasons. But again, our data set here is going to be very few records, so this will get us by perfectly all right. All right, going back into the terminal. So what we're going to do is we're going to open this project with our editor of choice. So I'm going to be using Atom by GitHub, but you could use Visual Studio Code, you could use something else. It's completely up to you. So I'm going to say Atom, and then I'm going to open it. Now before we actually start coding, we do need to include a few dependencies. So these dependencies include things like Couchbase SDK. It includes the URL router that we're going to be using. It even includes a dependency for generating unique ID values that we're going to use as document keys. So let's go ahead and start adding those. We're going to say go get github.com/satori/go.uuid. So this is for the UUID, and you only need to do this once. So once you have it, it'll save it to your Go path. Let's go ahead and say go get github.com/couchbase/gocb. And then finally, go get github.com/gorilla/mux. And this is for our URL router, which makes it a lot better than the one that Golang actually ships. Perfect. So we have our index created. We have our project dependencies downloaded as far as like the SDKs and stuff. Now we can worry about actually coding this project. So I'm going to open up the Go file, main.go, and we're going to add a few things. First of all, we're going to say package main, and we're going to import those dependencies. Or you know what, my editor will actually import them as we go along. I think if I save it and add them, it'll remove them because of the plugins that I have as far as this editor. So we're going to skip that for now. If it doesn't add them, I'm going to go back and add them manually. So what we want to do is we want to create our main function. So this is going to be func main. And what we're going to do here is we're going to say router colon equals mux dot new router. And let's see what happens when I save it, if it adds it for us. So say go get. I think I've been having some issues with my Atom, so it may fail. I don't know. There. So it added it for us. All right. So the next thing that we want to do is we probably want to add the endpoints that we're expecting. So this is going to be, again, an API type application. So some front end is going to communicate to this API. So what this means is we need to have an API for an endpoint for creating data, getting data, updating data, deleting data, things like that. So let's go ahead and start. We won't fill them in, but we will make them available. So kind of laying the foundation here. We're going to say func get person endpoint, and the values that we're going to pass here is W, and this is going to be our http.response writer, and request, which is going to be our http.request. And I'll go ahead and hit save, and you notice that in my editor it added this net HTTP package. So it's normal. If it didn't add it for you, go ahead and add it manually. We're going to add some more endpoints here. So I'll just copy and paste. So this next endpoint, we're actually going to call it get people endpoint. So as you can probably guess, the first endpoint gets one person. The second endpoint will get multiple people. So some more context on what we're building here. We're building an application where we can add people to the database. It's going to be very simple. We're just going to add a name, so first name, last name, and as well as an email address. But you can go ahead and make it as complex as you want it to be. All right, so now that we have the two get endpoints, let's worry about the next one. So the next one is going to be for creating. So let's paste it. We're going to say, create person endpoint. And I'm going to hit save. The next one that we want to do is we want to say update person endpoint. So you can see where I'm going here. And you can really name these whatever you want. Finally, what we're going to have is we're going to have delete person endpoint and hit save. So we do have all of these endpoints in place. They don't return anything. They don't do anything right now. So going back into our main, what we want to do is we want to link up those endpoints to the main function. So we can do it like this. We can say router dot handle func, so func for function. We're going to say in a string, we're going to say, so when somebody navigates to the slash people endpoint, what we want to do is we want to route to the get people endpoint. And it auto-completed a little bit too much for me here. So get people endpoint, and this one's going to be of method type get. The next one, so I'm just going to copy this line. So the next one is going to be for getting a particular person, and it's going to accept an ID. So it doesn't make sense to call this endpoint without providing an ID, so that way we can get that single person. And this one is going to be called get person. and it's also going to be a GET request. All right, moving along, we have our next one. So this one's going to be /person, and it's going to be, there's going to be no URL parameter there. This one's going to be for creating. So it's going to be create person endpoint. Now this one's debatable. So what we're actually going to say, this is going to be a put method. Some people will argue that creating data is a post method. It really doesn't matter here. If you want to look at good RESTful API creation, there's plenty of documentation online, and you could figure out what works best for you. All right, we have another endpoint here. This one is going to be for updating, and it will receive an ID because we need to know which data to update. And this will be update person endpoint. And this one will be a post. Finally, we have one more endpoint. This one will be for deleting, so we will pass in an ID still. And this one will be called delete person endpoint. And this one will be a delete request. So you can see we easily just linked up every single route function to our main function. So this is basic Golang stuff. It has nothing to do with really our database layer, but it is a requirement for creating a successful API. All right, so we need to serve this API. So we can actually serve it by saying, and we're going to log any kind of fatal activities too. So we're going to say log.fatal, and we're going to say http.listen and serve. And we're going to be listening on port 12345. It could be really whatever you want. That's on localhost. And we're going to pass in that router and save it. So it did complain here. Unexported name HTTP. It should actually go away as we start going. So let's ignore it for now. All right, so what we want to do now is we want to really worry about getting Couchbase hooked up to this particular application. So at the top above all of our functions, we're going to declare our kind of a global variable to this application. We're going to say var, and we're going to say bucket gocb.bucket. So that way we can actually use this bucket in every single one of our endpoint functions as well as our main. So let's go ahead and set it up inside of our main here. So what we can say is we can say cluster, and then we're not going to handle any kind of error response, equals gocb.connect, and we're going to pass it in the server we want to connect to. So this is a cluster instance, so it could be any IP inside of a cluster. So what we're going to say is Couchbase : // and I'm actually running it on a different computer on my network, so I'll go ahead and enter that. Just like that. You don't need to worry about the port. It'll handle it for you. But just go ahead and pick a IP or a host within that cluster. Now we want to open up a particular bucket using our freshly created global bucket variable. So we're going to say bucket. And we're going to say we don't want to handle the error. Equals cluster dot open bucket, and the bucket we want to use is called example. So that's the one that we have already set up in Couchbase as of right now, and it errored on us right here because we actually don't have a password. So add that extra parameter there. If you have a password, go ahead and set it, but my application, there's no password for my particular application. All right, so now it comes down to really creating our endpoints. So we really need to figure out what is each one of these endpoints going to do. But before we can do that, we have to define our data model within the application. Now, Couchbase being NoSQL doesn't really depend on a data model, but our application will depend on a data model. So let's go ahead and create a struct at the top of our code. So we're going to say type person, and it's going to be a struct. It's going to have an ID, which is a type string, we're gonna reference JSON. So we're gonna map it to JSON. We're gonna say JSON ID omit if empty. So we're gonna exclude it if it's empty. We're not gonna include it in our save. Let's go ahead and add a few more here. Let's go ahead and say first name, which is also a string, and we're going to map it to some JSON here. So it's going to be first name, and again, this is what it'll look like in Couchbase. So even though that our variable is called first name with a capital F, it's actually going to be first name with a lowercase inside of the database. Omit empty, and let's go ahead and save it. Let's go ahead and add another one here. Let's say last name, JSON, and then omit empty because we don't want to save blank properties inside of our database. And finally, we're going to say email. Perfect. So this is our person object, or our person structure. But we're not done yet, though. We really need to be able to handle how data is expected to come back. So let's actually worry about that last. We won't worry about that quite yet because I want to make sure that it makes sense to you when I add it in. So we're actually going to add another structure, kind of a wrapping structure, but we won't worry about that quite yet. So the first thing we want to do is we probably want to worry about creating data. So let's jump right into that create person endpoint, because if we were to test any of the other endpoints, they wouldn't work because we don't have any data to work with. So first off, let's go ahead and say var person. So we're going to start off with that struct that we just created. Next thing we want to do is we want to be able to pass parameters in here. So what we're going to say is we're going to say N1QL params. This is going to be an interface, so an array of interface. All right. So the next thing that we want to handle is we need to decode the JSON body that gets passed into this request. So if you're familiar, any kind of put and post request, you're working with JSON bodies, and we really need to be able to parse that first. So we're going to do the following. We're going to say equals JSON.new decoder. So we're going to use the Golang JSON decoder. We're going to take that request body and we're going to decode it into our person. Oops. Perfect. So anything that's inside of our JSON body, it'll get mapped to whatever properties are inside of our person structure. Because remember, we did mappings for JSON when we created it. All right. Next up, now we want to worry about querying. So by querying, I don't mean reading data, I mean writing data. And there's numerous ways to do that with Golang. We're going to do that strictly with NQL. So what we can say is we can say the following. We can say query equals GoCB dot new NQL query, and now we can type in our statement. So if you're familiar with SQL, this should be rather familiar to you. What we want to say is we want to say insert into example, and it's going to be key value values. So this is going to be a parameterized query. Remember, I said NQL params. The parameters based on what was in that JSON body. We're doing parameterized queries, so that way we fight off any kind of SQL injection attacks. But we're going to say parameter 1, so that's going to be our key, so our ID. And then we're going to say inside of single quotes, we're going to say first name. And that's going to be referencing parameter 2. We're going to say last name. That's going to reference parameter 3. And then finally, we're going to say email. And that's going to reference parameter 4. And we can save it at this point. All right, so now we need to worry about extracting those parameters. So let's go ahead and say N1QL params equals append, and we're going to say N1QL params UUID dot new v4, and then we're going to cast it to a string. So this is our document ID. It's going to be a unique value, and we're going to see what that looks like in Couchbase after we save this document, after we really construct this API. The next parameter, N1QL params, and we're going to append another item to it. We're going to say N1QL params. We're going to say person dot first name, and then let's copy this a few times. We're going to change this to last name, and we're going to change this to email. So all of our possible parameters are now added to this. So let's do the following. Let's say we're actually going to do our execution of the query. We're going to capture the error response. If there is one, we're going to say bucket dot execute nickel query. The query being query, and the params being N1QL params. All right, now we need to see if there was an error. So if there was an error, it won't be nil. And we're going to say w dot write header. Oops. We're going to make sure it's a 401. So you could do whatever kind of error response you want. We're going to say w dot write. It's going to be a byte array here. Error dot error. And then finally, we'll return out. So we won't progress any further in this function. Otherwise, if there was no error, we can say that it was successful. We can say JSON dot new encoder w dot encode person. All right, so we should have a functional first endpoint, at least something to go off of for now. So let's see what happens when we try to build it. And I'm not sure why it's still highlighted. I may have a typing mistake. So let's check it out. We're gonna, from our terminal, we're gonna say go build. So it did error. So it errored. Further looking at it, it looks like I have a lowercase l, which was, I missed it. We want it to be an uppercase L in listen and serve. So let's go ahead and build it again. So it is built. So now let's try to run it. So we're going to say run CB project, and we're going to actually go to a tool that I like. It could be any tool that you want, but I personally like Postman. So this will allow us to test out our API, because again, we don't have a front end. So what we want to test here is we want to say this is going to be a post request. Sorry, it's actually going to be a put request for person. And it's going to have a JSON body. And this JSON body, it's already entered in here because I've done this before. But this is what it looks like. It has a first name, last name, and email, all lowercase, and values. So I'm going to hit send. And as you can see, the response was the person structure, because that's what we chose to return. So if I go back, and if I go into my web browser and I click on data buckets, and I click on example, we do have one piece of data in there. This one piece of data has a key, being that unique ID value, and it has that JSON data that we saw in our response. So going back to our code here, we can actually start working on the next endpoint. So it makes sense to make our next endpoint a kind of get all endpoint, followed by, we'll of course do a get particular. But let's go ahead and get people. So for get people, what we want to say is var person, and this is going to be, of course, an array of person. What we want to do is we want to write a query. That's going to be go cb dot new nickel query, And our statement will look something like this. Select star. So this is going to be all properties from example. And we'll call this as person. And remember, I mentioned it earlier. This is where things might get a little weird. Oh, hold on, I have a mistake here. Oh, it's not used. All right. So like I said, things might get a little weird here. So if we type in that exact query into our query editor inside of Couchbase, we can say select star from example as person, execute. You can see that we of course get an array of data back, but each object in that array, it kind of has a wrapping person property on it. So this is why we need to create a wrapping structure for our person structure. So that's not hard to do. What we're going to do is we're going to do the following. We're going to say type N1QL person struct, and then of course there's plenty of other ways to do this as well. But this is just one way. This is my preferred way. So what we're going to say is we're going to say person, and of course we're going to map it to some JSON. And this is going to be person. This is going to be a capital, sorry. All right. Now we can start completing this get people endpoint. So what we want to say is we want to say the following. Rows, because of course we're going to expect an array of data. Underscore, because we don't really care about what the error is in this case. Equals bucket.execute nickel query, where we're going to pass in the query. And in this case, there's no params, so we're going to leave it as nil. All right, so now we need to handle the result. So we're going to say var row nickel person. So remember that it has an exterior wrapping to it, like we just saw. What we're going to say is for rows dot next ampersand. Oops. There we go. I can't seem to type today. Row person equals append person row dot person, because we're getting a list of nickel person here. All right, so we loop through it. It's now assigned to person. This and now what we want to do is we want to return it. So we can say JSON dot new encoder. We're going to use W for writer, and we are going to say encode ampersand. Nope, no ampersand person. All right, so let's go ahead and test it out. We need to rebuild it. And for future, I'm just going to add some ampersands in there, and I'm going to say CB project, so that way it'll build and run it at the same time. Going back into Postman here, we're going to change our endpoint to a get endpoint. We're going to say people, and we're going to send. So here we have an array, and we flatten it out. We removed the upper layer to it, which is good. And there's of course only one result. So let's go ahead and add another result here. Let's go back one level to our put. We have our body. Let's go ahead and say Arun Gupta, and we'll say Arun at test. Send it, and let's try to get all of our people again. So another item has been added to this array of objects. So that was very easy so far. Now we need to worry about the few other endpoint functions that we have left. So let's go ahead and handle get person endpoint. And this wrapper, it will be used again. So we're going to say var nickel parameters, and this is going to be an interface array. And we're going to say query GoCB dot new nickel query, and our statement will be select star from example as person where
And so if you recall our document, we're actually not storing the ID inside of the document itself. We don't need to do that. You can, but we don't need to. So if we don't need to, maybe we shouldn't. So in this case, we're going to get the ID from the meta information about the document. So we're going to say meta person dot ID, and then of course this is a parameterized query to prevent any kind of injection attack. So parameter 1. So params is going to equal mux.vars request, and then N1QL params equals append N1QL params ID. So the particular parameter that we want is going to be called ID, which if you scroll down to the bottom here, if we look at our get person endpoint, we actually called it ID. So if we called it something other than ID here, it would need to match up here inside of our param. So with that out of the way, now we can actually execute the query. So we're going to say rows. We're going to say bucket.execute, and we're going to say query. And for params, it's actually going to be N1QL params. And then what we want to do is we want to return the first result, because we only expect one result. If you want to expect otherwise, you may need to manipulate your query a bit, because our query is rather vague. But let's go ahead and say one result. We're going to say var row N1QL person. And then we're going to say rows.1. And we're going to store that inside of row. And then we're going to return it. JSON new encoder. So the same stuff we've seen so far. Dot encode. And we're actually going to return row.person, because we don't want the upper layer to be returned. So let's go ahead and save it. This should actually be singular. That's why it has an error. Nope. Actually, my bad. I just saw that we created a singular one below it. So saving it again, it seems to have fixed itself. So let's go ahead and rebuild. All right, expecting. All right, so I have something. Oh, I forgot my equal sign. So it should be colon equals. All right, building it and running it. Going back into Postman, I'm going to get a particular ID from the database here. So in this case, I'm going to just copy the ID. I'm going to bring it into Postman. I'm going to say person. I'm going to add the ID to the end, and then when we run it, it should work. All right, so it returned one item. It is not an array, it's one object, exactly how it should be. All right, let's go ahead and wrap up the rest of our endpoints here. So a few more, and they're all going to be very similar at this point. We've really covered all of our ground now. But let's go ahead and handle an update scenario. So in the update scenario, it will be similar to our insert scenario, but we're going to say var person. We're going to say var nickel params. And of course, that's going to be an interface again. We're going to say underscore equals JSON dot new decoder, because remember we're working with JSON bodies again. So this is going to be request.body decode ampersand person. The next step is we want to construct our query again. Go cb dot new nickel query, and our statement this time is going to be an update statement. So we're going to say update example use keys $1. That's our parameter. So this is going to be one particular key. Set first name equals second parameter. Last name equals third parameter. Email equals fourth parameter. And like I said, There are many different ways to accomplish this task. This is just the way that we're choosing to do it right now with nickel queries. So we can go ahead and save it. Now we need to populate those parameters. So again, let's say params equals mux.vars. And we're going to say N1QL params equals append N1QL params. This one's going to be params ID. So this is, remember, this is an update. We've provided a param for ID. Let's go ahead and copy that line. The next line won't be an ID. It won't be from the URL params. It'll actually be from our person structure. So we're going to say person.firstname. And we're going to do the same for everything else. So you can see it's pretty much the same as what we saw for the insert. Just this time, instead of generating a unique ID, we're going to use the ID that was passed, so that way we can update our data. All right, now what we want to do is we want to run this query. So we're going to keep track of the error. So bucket.execute nickel query. It's going to be query N1QL params. If there was an error, so if it's not nil, we're going to say w.write header. It's going to be a 401 response. We're going to say w.write byte error.error, and then we're going to return out of this. Otherwise, we want to return exactly what we saved. So we're going to say JSON.newEncoder w.encode, and we're going to say person and save it. So we won't go ahead and test that out. Let's just assume it works for now. We're going to handle our delete endpoint right now. So our final endpoint, but everything we've done up till now will hold true for this as well. So we're going to say var N1QL params. And what we're going to do is we're going to construct our query. Go cb.new nickel query. It's going to be delete from example as person where meta person.id equals a parameter. All right, so let's go ahead and fill those parameters. So we're going to say params equal mux.vars. So the request, I'm going to say N1QL params equals append N1QL params ID, because that's what we called it. And now we're going to execute this query. We're going to say the same thing again. Bucket.execute nickel query, and then N1QL params. If there was an error, we're going to go do the same things again. So w.write header 401, w.write byte error.error, and then finally return. Otherwise, we're going to say JSON.newEncoder w.encode. And this time, we're actually going to encode ampersand, if I can find it, ampersand person, and this is just going to be an empty person because we've deleted it. There's no need to really present what we deleted. We'll just present an empty object in this case. So let's go ahead and test out everything works up until now. I just saved it. Let's go ahead and rebuild it. Oops. Going back into Postman, let's go ahead and delete this particular record. Oops. This will be a delete request. My ID is still up there. I'm going to say send. It returned an empty object. If I go back here, of course, that record was deleted. Let's go ahead and say We want to edit this email address. So let's go ahead and take this ID. We're going to go to Postman. We're going to paste it in. We're going to change this to a post request. I'm going to go to the body. We're going to keep it as Arun Gupta. But instead of just Arun at test, we're going to say Arun Gupta at test and see if this works. Send. So it looks like it worked here. So if I refresh, it now says Arun Gupta at test.com. So going back into our code here, just a quick recap because we did a whole lot here. Well, at least it took a while for me to type this all out. But we created our new Golang project. We actually got various dependencies being Couchbase Go SDK, the MUX URL router, the UUID package. We created a person struct and really mapped it to what it will look like in the database. We created this exterior layer to avoid having to really worry about the parent object. Again, there's other ways that you can do that. If we scroll down to the main, we connected to our Couchbase cluster. We opened up a particular bucket. We linked up various routes to their appropriate functions and decided what method it'll be, as well as if there are any parameters. And we started serving. And then each one of these URL route methods has a nickel query in it, where we passed in some kind of parameterized query to either read or write to the database. So you can actually use this in any Golang application. Go is very fast, and it's a great candidate for working with Couchbase.